Alright, today we're going to change the spark plugs on a 1998 Saturn single overhead cam. The tools you're going to need for this job are a spark plug wrench, which has the 5/8 size socket with the rubber boot inside to get hold of the spark plug as it's loosened. Some anti-seize for the threads on the spark plugs, and your 4 spark plugs. Now all the spark plugs are located at the end of these boots right here. 1, 2, 3, 4. And to take these boots off, all you have to do is just grab it right here at the end. Make sure you grab it right there, not right here, because if you pull on this part, it can rip out and damage the whole plug wire, and you have to replace that. And I don't think you could buy those individually, you have to buy them as a set. So make sure you get it at the end and just turn and pull. It should come out really easy. Just move that aside. Alright, now after you get the boots off, what I like to do is to get some dust remover, any kind of compressed air, usually for computers and stuff. Sometimes, depending on how long the job is that you've taken the spark plugs out, there can be some debris down there. I'm sorry that the lighting's so bad, but I checked these earlier before I bought the car, and there was some debris down there, so I use the compressed air before I take the spark plug out and shoot all the debris out, so when the spark plug is out, none of the debris gets into the engine and potentially cause some damage. So that's what I'm going to do right now. Now before you do this, you may want to do one of 3 things. Just close your eyes, or turn your head, or get some goggles on, because you don't want any of the debris to basically backfire and get any in your eye, if there's any in there in the first place. That should be pretty good. Now that the dusting's all done, you just get the spark plug wrench and put it in there around the spark plug, and just twist away so it comes out. As I said earlier, the rubber boot should catch the spark plug, so you don't have to worry about it falling anywhere. Like this. See, it won't come out. And then you just pull them all out, and inspect them for any damage or signs of oil leaks, broken head gaskets, stuff like that, water, oil, white powder. We'll get into that later to show you what the difference is and what to look out for. But for now, we're just going to take these all out so we can replace them with the new ones. Alright, now we have to gap our spark plugs. I came into the car and brought my light so we have better seeing ability. I got this gap tool, very basic gap tool from AutoZone, obviously. It says AutoZone on it. And these numbers in here represent the space between the electrode and the tip of the spark plug. The bigger the number, the bigger the gap. As you can see here, the space right there, the metal piece gets bigger and bigger and bigger as I turn it. All we got to do now is just put this little part right here, piece of metal, the brim, into the middle of that gap in the spark plug and see where we measure. Well, the guy at AutoZone said that These spark plugs are supposed to be at 0.040. As you can see, the spark plugs that I have are a little bit past that. From what I hear, it's okay to be a little bit past or a little under, but I like to be direct. I'm just OCD like that, I guess. So basically, if it is too big, like how it is here, you just take the top of the electrode and you smash it down with obviously a harder object. Just put a little bit of weight on it, and that pushes that down closer to, or take the tip of the spark plug and push it closer down to the electrode. Now, if it were smaller, let's say at 0.035, you would put the gapping tool in the middle of this. I just dropped it, but how it was before, and pull up, which will pull the end of the spark plug away from the electrode and create a bigger gap. Then from there you just keep measuring, plus or minusing, until you get to the designated gapping space for your engine. Alright, so now I just re-gapped the spark plug. Now it's directly in the middle, right at 0.040, and I got to do that to the rest of the spark plugs. So from there, after I'm done with that, I'll show you how to put on the anti-seize onto the threading of the spark plug, and then we'll reinstall. Alright, now that we're done gapping, we take the spark plug and get the anti-seize. I like to snip it right at the edge right here, make a little snip, and squeeze until a little bit comes out. There we go. And then just take it and wipe it onto the thread. Not too much though. Make sure it doesn't get on the electrode, and just turn it around and barely push out as you're turning it to where it gets all over the threading. This especially helps if you don't have gloves, so that way your hands don't get all gumped up. But that's basically it right there. And then just put the plug back into the wrench, and then install the new plug back in its place. Alright, now all the plugs are back in their places down there. And the 1, 2, 3, and 4. And now it's just time to put the plug wires back. And to do that, you just make sure that the hole just goes right on top of that spark plug. And you will know that if you did it right, because you hear a little like popping or snipping sound, if you want to say. I'll try to get it on camera so you could hear it. There you go. Little snip. And you just do that to all 4 of them. There you go. There we go. Snug as a bug. Alright, in this part of the video, we're just going to check out the common spark plug conditions. Basically what you can expect, potentially expect, when you pull out your spark plugs. Here's a picture of a normal wear and tear spark plug. It says symptoms: brown to grayish tan color and slight electrode wear. Correct heat range for engine and operating conditions. Recommendations: when new spark plugs are installed, replace with plugs of the same heat range. Warn, there's the picture. Symptoms: rounded electrodes with a small amount of deposits on the firing end. Normal color causes hard starting in damp and cold weather and poor fuel economy. Recommendations: plugs have been left in the engine too long, replace with new plugs of the same heat range. Follow the recommended maintenance schedule. too hot of a plug. There's the picture. Symptoms: blistered white insulator, eroded electrodes, and absence of deposits results in shortened plug life. Recommendation: check for the correct plug heat range, over advanced ignition timing, lean fuel mixture, intake manifold vacuum leaks, sticking valves, and insufficient engine cooling. Below that one, that's the picture. Pre-ignition. Melted electrodes, insulators are white, but may be dirty due to misfiring or flying debris in the combustion chamber. Can lead to engine damage. Recommendation: check for the correct plug heat range, over advanced ignition timing, lean fuel mixture, insufficient engine cooling, and lack of lubrication. Across from that is carbon deposits. That's the picture. Symptoms: dry city deposits indicated a rich mixture of weak ignition, causes misfiring, hard starting, and hesitation. Recommendation: make sure the plug has the correct heat range, check for a clogged air filter or problem in the fuel system or absent or engine management system. Also check for ignition system problems. Ash deposits. That's the picture. Light brown deposits encrusted on the side of the center, or center electrode, or both, derived from oil and or fuel additives. Excessive amounts may mask the spark, causing misfiring and hesitation during acceleration. Recommendation: if excessive deposits accumulate over a short time or low mileage, install new valve guide seals to prevent seepage of oil into the combustion chamber. Also, try changing gasoline brands. High-speed glazing. Picture. Symptoms: insulator has yellowish glazed appearance. Indicates the combustion chamber temperatures have been risen suddenly during hard acceleration. Normal deposits melt to form a conductive coating. Causes misfiring at high speeds. Recommendation: install new plugs. Consider using a colder plug if driving habits warrant. Detonation. Insulators may be cracked or chipped. Improper gap setting techniques can also result in a fracture. A fractured insulator tip can lead to piston damage. Recommendation: make sure the fuel anti-knock values meet engine requirements. Use care when setting the gaps on new plugs. Avoid lugging the engine. Picture. Oil deposits. Oily coated caused by poor oil control. Oil is leaking past worn valve guides or piston rings into the combustion chamber. Causes hard starting, misfiring, and hesitation. Recommendation: correct the mechanical condition with necessary repair and install new plugs. Picture. Gap bridging. Symptoms: combustion deposits lodge between the electrodes. Heavy deposits accumulate and bridge the electrode gap. The plug ceases to fire, resulting in a dead cylinder. Recommendation: locate the faulty plug and remove the deposits from between the electrodes. Picture. Mechanical damage may be caused by a foreign object in the combustion chamber or a piston striking an incorrect reach. Too long. Plug causes a dead cylinder and could result in piston damage. Recommendation: repair the mechanical damage, remove the foreign object from the engine,
and/or install the correct reach plug.